To me, it's a highly interesting topic because aviation is always seen as a very innovative area, and we understand that civil aviation is a very conservative area because all novelties should be tested and well proven, and we have a common problem that innovations should not exist independently, but we need a cycle where innovations that originate from the scientific, from the research community, little by little they are used in industry and serve the people. So I think this is the key message to unite all our presentation. So now I would like to give the word to Mr. Valery Okolov, Deputy Minister of Transport. Thank you. Good morning, dear colleagues. Well, indeed, aviation subjects implies breakthrough and innovative technologies despite the good deal of regulation that exists in the civil aviation. So in my brief presentation, or rather review, I would like to highlight three innovative points that have huge potential for development in the short term, in the nearest future, and that already have some reserve. So I'm not talking about some prospects, but about projects that are currently being implemented for the sake of national and world economy. So the first project is e-freight, electronic follow-up and transportation of luggage. Just a few years ago, we all used hard copy tickets, but now we became all accustomed to e-ticket technology. So this is something that broadens the opportunities for travel agents and for passengers. It's a reality. But e-freight is a much more complicated project, and it has to do with the fact that unlike e-ticketing, it's not something obligatory for the industry, and only airlines and airports and administration that will implement the technology will gain an advantage in attracting cargoes and in cargo transportation, and hence they will get some new transportation flows both in general cargo and in belly cargo, and hence will get the share of the business. So in the Russian Federation, this technology has been introduced for the third consecutive year as a pilot project, and we have Volga-Dnieper Airfloat Airlines engaged in the project, and we also managed to get involved Lufthansa Cargo and Cargo Lux to be part of the project, and also Singapore Airlines, Emirates are interested in the project. So Домодедово, Шереметьево, Пулково, Кольцово, Екатеринburg, and Tolmachovo of Novosibirsk, Емельяново in Krasnoyarsk, and Novi Airport in Khabarovsk are all being part of the project. This technology on serving transit via Russian Federation has been well proven. So the cargo planes have a number of stops on the way from the southeastern Asia to Europe, and they have stopovers in either Novosibirsk or Krasnoyarsk, and there were some trial flights on cargo transfer. And only 3 months ago, Cargo Lux and Lufthansa Cargo became part of the project. So, and at the moment, there is a a package of hard copy documents available in the pilot's cockpit available, and the flight is a success when no hard copy documents are required, neither for the border control or for the customs, nor for the phytosanitarian control. So then we can say a flight is successful. So at the very beginning of the project, we came across the fact that in Russia we don't have any uniform data platform that would support such data exchange of e-documents between public agencies like the customs office, the tax office, the border control. So we had to begin with building up the platform, and we were based on the Federal Customs Service, which at that moment of time was the most advanced in terms of information. And today, this data platform of the customs office is being enriched with data resources of other public authorities of the executive branch. And from the point of view of logistics, the project proved to be quite complicated in terms of organizing interaction between different branches of the power. So, and what's the outcome? The outcome is attractive organization of transit via the Russian Federation, and one of the main cargo direction in the world trade is Europe to South Asia, and our aim is to gain that money available in Europe and in Southeastern Asia to make them come into Russian budget. So ideally, when cargo is transported from China to Novosibirsk and then to Moscow, it's collected and then transported to either Europe or regions of the Russian Federation. And due to creation of a uniform customs union, customs administrations of both Kazakhstan and Belarus got involved into the project. And I would not say we are at the very beginning of the project. However, it's far from its completion, because further on we would like to transform e-freight into e-cargo. It would be a much more advanced project, which would imply electronic follow-up and producing shipping documents not only for air transports but for all types of transport, and later on creating a multimodal system of transport from air transport to trucks. We will imply for interaction between rail transport and trucks, and also sea ships with trucks, and we will get a new quality of logistical product. So the cargo, the transportation and the money will be available to the operator, which will support the electronic platform, because at the moment the parties sending and receiving cargo are focused on that technology, because it enables tracking the cargo in well, 24/7 to 52, and it allows to amend logistics of the cargo online and to find the best possible distribution channels for the cargo. And for Russia, it's highly important that this technology and this logistics should be implied in our transportation system. 44 aviation administration have already implemented that technology at different levels. Some were more advanced, like in countries like the Netherlands and South Korea. Hong Kong and Singapore made impressive progress, and we are thankful to our colleagues which are really interested for Russia to implement this technology as well. So this is in brief on e-freight technology. The next promising technology I would like to cover is called automatic surveillance, and it has direct link to unmanned machines. So at the moment, the technology is built upwards because a plane sees a locator from the distance of 300 kilometers and at a height of 10,000 meters. However, if you have an aircraft at the height of 1,000 meters, so it's seen by a locator at a distance of 50 kilometers. So it's technically possible to provide for the network, but it's very expensive because of the landscape, marshlands and mountains. So taking into account the distances in Russia, it's impossible. So we would like a GPS technology to be used to locate unmanned aerial vehicles, airplanes, helicopters, regardless of its height and regardless of the terrain, because the principle is different from downward from the top. And the question is how to organize communication channels. And if all aerial vehicles which are flying could be equipped with the system of e-surveillance, so then we would have internet in the air when all aircrafts would see each other, and a flight commander would have complete information on his environment. That would be the highest level of the information provided to the flight commander. Then airplanes would become transponders, airplanes and helicopters, and they would inform each other on the location, on movement vector, on the height for every aircraft. And this picture would be reproduced on the display of an aircraft, also of the flight control authorities, and also of the airline, of the airport. The airport will know which aircraft is departing and which is arriving, and that will bring the safety in flight organization to a new level. To give you an example, with the Malaysian Boeing lost over the Indian Ocean. If we would have that system in the flight space, it would be impossible to ignore its location, because every aerial vehicle would communicate on its position. And now we don't know where to find this Boeing plane. As for unmanned aerial vehicles, they are in use, but the question is how. Because to launch an unmanned vehicle, you need to put a ban on flights or restrict flights at certain heights in order to avoid a conflict in aerial movement. So this system of automatic interdependent surveillance would enable us to use unmanned aerial vehicles in the same space together with aircraft, with airplanes and helicopters flying, following different paths and at different heights. The use of unmanned aerial vehicles would have great economical effect for the survey and for tracking the ambient environment, like forest fires, to monitoring gas and oil pipes and other extended networks. So currently airplanes or helicopters are used to this end. For instance, Mi-8 helicopter is used to fly over a gas pipeline, but you can imagine what the cost is for an hour of flight time. Well, it's about 10,000 US dollars. A use of unmanned aerial vehicles would enable us to cut down the costs. And so the one who will implement the technology will get orders from Gazprom, from Rosneft, and other oil and gas companies are the customers. They will get orders from the federal budget, which at the time finances flights over woods as part of the forest monitoring programs. Some orders will come from the agricultural producers, because as for today, unmanned aerial vehicles are used in agricultural aircraft fleet, and this should go in line with the automated surveillance system, which would allow us to use unmanned aerial vehicles without putting bans or restrictions on the flights. And to this end, we need to equally promote these two technologies. They are closely linked together, and of course the automated surveillance system is important for all types of aircrafts. But as for unmanned aerial vehicles, they are useless without this technology. Thanks for your attention.
Thank you very much, Vladimir Mikhailovich. I don't know, maybe we have time for a few questions and then we move on. But please wait while the microphone arrives at you. My name is Andrei. I represent... Please switch on the microphone. Пусть включит микрофон. Микрофон не работает. No microphone. You said microphone is turned off. Microphone is off. Пусть включит микрофон. Микрофон пусть включит. Микрофон включите. Мы не слышим.
То есть у нас нет необходимости подниматься какие-то высоты в нормальном режиме движения, в основном режиме движения. То есть только когда нам нужно когда-то каких-то этапах будет подняться, мы только время это делаем, готовы, чтобы лететь на дальнее расстояние,
Спасибо.
Thank you very much for your question. The risk collision exists not only in the 3D but also in the 2D environment. And in 2D space, the risk collision is higher by an order of magnitude because one axis of dimension is missing. And use of the special airplanes or unmanned aeronautical vehicles without an operator still does not exclude the possibility of collision with other flying vehicles moving along the water surface or some other surface. So here it's very important that all actors of this traffic be equipped with equipment which would allow them to have understanding about the situation, to be aware about the situation, about some crossing movements or opposite movements, and to have the alert system about a possible collision. Today, all aircrafts are equipped with the early warning system, and these aircrafts are interacting between each other. This equipment is in place. Here, at least the same kind of equipment should be installed on all traffic vehicles which could have this risk of collision. Thank you very much for your question. I think we can move on along to our agenda, and at the end should have time for question and answers, of course, if we will work efficiently. Now I'd like to give the floor to Sergei Leonidovich Chernyshov, Executive Director of TSAGI Center, and we will listen to his presentation about the innovations in the area of science. Thank you very much, dear Chairman, dear colleagues. The topic of today's forum is innovation, and innovation in airspace, in aviation, in aircraft building. Could you please switch on another billboard here? And basically speaking, we can have a speech on behalf of the science, understanding that all new aircraft and flying objects are all innovations in this area start, of course, from the deep research in this area, from the building of so-called scientific baseline, which is a key to success here. A few words about myself. I work in TSAGI, in the biggest research center globally, concentrating in one place, experimental equipment, testing equipment, specialists and experts in all aspects related to aircrafts and flying vehicles. This is the scientific baseline, which is a foundation to all innovations. It cannot come out of the blue. Of course, innovation is different to other areas in the fact that the aircraft construction has a very long cycle from the idea to the real sample. It's more than 10 years. And in the modern format, we try to reduce this cycle time, but anyway, it's very tedious and big job, including a huge number of research work in the area of new technologies. And I'd like to mention also that here the state plays the key role in the aircraft building of all countries. State programs play a very important role, and Russia is not an exception here. Our new state federal program of development of aviation industry for 2013-2025 plans around $27 billion for the period of a little bit more than 10 years. And one of the core area in this program is in particular the National Research Plan and the New Technologies Development Plan. with the total funding volume around $6 billion. $6 billion should be spent on science and technologies, and these are the scopes which are comparable to similar works and financing in the developed countries such as US, France, Germany, and others. So I can stress it in this audience that we work on the partnership basis with European research programs having very powerful funding sources, and also we cooperate with Canada and with the US programs in the pre-market research and in the way of bringing to market new technologies. The main strategic document of our national plan of research and development is a foresight. It's a kind of a foresight or forecasting document as a research strategy which covers the four main research areas of the science. Of course, the baseline moment in our strategy are those future requirements to aircrafts which is set by the global market. First of all, this is the operator of aircraft, the airline, the traffic market, leasing companies, and other actors. Basically, the whole global aviation society builds up the perspective on how the aviation should look like by 2020, by 2030, and further on. And here we see very strict requirements in terms of the 5 times growth of flight security by 2010, and 10 times by 2030, reduction of emission of CO2 and CO, and NOx emission reduction also, and the noise reduction. These are main baseline drivers, if you may, for our research and for building up technologies in the aviation building today. They all are based on the requirements, and our research are also in line with these requirements. There are 4 main pillars, 4 main areas in our foresight, in general, in the development of the technology. This is the new configuration of flying objects, which provide the huge growth in the efficiency and satisfying of the global requirements to aircrafts. These are new engines and their integration in the airplane. The engines with open rotors, with the distributed power unit. These are new materials and new structures made of these new materials, of course, including the wide use of composite materials and the new onboard equipment, first of all, avionics and other systems. These are 4 main areas of development, of the innovation development in the aviation area. As an example, the realization of this foresight in the short term, up to 3 years, we launched, I mean here, using the financial support of the ministry and the Joint Aviation Building Corporation and Scientific Institute, our institute, we launched such integration project, which in a matrix form shows how these foresight strategies are realized for a short term of 3 years. We deal with new combinations, with new engines. We look at the effects of new composite materials and the implementation of new constructions, and of course new systems and avionics. And we initially there were 5 areas. Now we narrowed it down to 4 main areas. These are long-haul flights and mid-haul flights, also wide-body flights, regional flights with very high green and environmental characteristics. These are ultrasound business airplanes with a low noise level, and the transportation civil plane with a short landing and takeoff distance. And we use new technologies in these configurations and look at the effect. I hope that my colleague Leonid Kom, Vice President of LAG company, would present more details about it, because it is very tight cooperation between the science and our main aviation building corporation. As a result of our cooperation, I'd like to demonstrate you here one of the solutions that we work on in detail. These are such solutions as flying planes or combined blended wing body aircrafts, where there are lots of innovations, different ultra high two-circuit engines and new solutions on surfaces. This is an active management of load on the aircraft in order to drastically reduce the weight of the construction and to increase the life cycle, and so on and so forth. One of the elements is, of course, the wide use of composite materials, such isogrid constructions. And the source, the motherland of this idea is Russia. And these constructions were used in the rocket building industry, and together with UAC, we look at the possible use of such exotic configurations, and as a result, we get very good characteristics and very good parameters of performance in all areas. Significant reduction of weight, significant reduction of fuel consumption, and of course such exotic new types of aircraft such as ultrasound solutions. Russia was the motherland of the first ultrasound passenger plane Tu-144, and now we work on some business type planes, and our main partner OAC here is naturally develops different constructive peculiarities of such solutions. This is just a picture, but on the background there is a bunch of brand new technologies which would move forward not only aviation building but also other industries of our economy. And finally, an international project together with the EU and Australia. This is a dream of the humankind to fly higher than the sound speed in the 8 to 7 times higher hyper sound aircraft. This is just a dream, just a concept, but we set the target together with our partners from Europe and Australia to carry out demonstration of such aircraft by the year 2018. The work is in the full swing. The financial program is around 50 million euro, and we hope for the successful demonstration of these aircraft. We should start something. Our dream, of course, is connected with new aircrafts, and I hope that once we will fly such planes which have very high economic characteristics, high comfort, high level of comfort, low emissions, and absolutely safe in the air. Thank you for your attention. Thank you very much. I think that because we're a little bit out of schedule, I think we will have the discussion at the end. Now I'd like to give the floor to Leonid Anatolievich Kom, Vice President on innovation programs of LAG company. Now we move from the science to the industry. Dear colleagues, dear guests, dear representatives of the press, it's clear that the aviation industry, it's a very high-tech industry. Moreover, it is one of the powerful drivers of the economy with a big multiplier. It confirms that the aviation technologies, they lead not only the aviation building industry, but are used in the majority of other industries of the economy, and they are translated practically to all these industries. So the state is puts the aviation building industry on one of the priority places supported by the government. And if we look in general, globally, it is very hard to find an industry except for aerocosmic industry, which has such strong financial support of the state. Practically all countries in the US, in China, in Europe, everywhere, this is the most supported in the financial terms industry. It is clear that in order to build airplanes, we have to have very strong science and to use the results of scientific research that our institutes lead. I'd like to draw your attention to the fact that the life cycle, the lead time of an airplane construction is very long. It is 10 years. It means that if we design a plan and we design some solutions during these designs which are proven and tested and which are tested for the current moment, it means that in 10 years from now, when the airplane will go to market, it will be already outdated for 10 years.
So that's why the specific about this industry is that when an aircraft is being designed, we have to provide for the process and scientific related, which are not 100% proven, which are at the very conception stage, which are not at the highest development level. So I would like to pay your attention to this simple slide, which is the backbone of our cooperation with the researchers. So if you take a look at this slide, you will see that it is quite simple. You will see that to create an aircraft, a large volume of research is required to create that baseline. And if you plan for some 5 or 7 or 10 years, so the initial scope of research is much higher than the scope of designers' work. And as the design works develop, you will see that the R&D grow, and you see the red line on the slide, which is a border, which show that by the time feed stage is reached the reference point 4, the technology should reach the TR6 level. So that was for the first time in our country that together with TSAGI we introduced this process readiness index, because it is an unbiased estimate, because previously we were talked about technology being ready, but designers would tell us, we cannot apply it because it's not proven and would give us 20 reasons against it. But now we have the base for a smooth transition from developing terms of reference to developing the product itself. And the complexity of the process is that when the processes of developing terms of reference and the product itself, they go in parallel. And you have a period of time when you work over some research projects over the design of the aircraft as such. So, and before we had that crossing point, which was the black spot in between research and production, and it's very hard to bridge this gap in all countries of the world. And the science shares its results and takes it up to the second or third level, but the industry needs at least to level 6 in order to use it in to use products in an aircraft. And the question is, who has to bridge this gap? Who has to coordinate for the processes? How to ensure the widest possible use of scientific developments in a future aircraft, which will be developed in 10 years' time? And will it be 10 or 4 years obsolete at the time it's made? So that will be a decisive factor of whether it's competitive or not. So together with our partners from SAGI and other research institutes, we launched a research program, Airplane 2020, which focused on a number of issues. So first of all, marketing research, in order to find free niches, free segments for the potential breakthrough in the world market. The second part was analyzing all existing and promising airspace technologies, analyzing who could bring them to the required level, also analyzing the costs and who had the capability of doing that. And for today, we have a valuable database. So, for instance, if we would start to work over a new plane, we will know what technologies could be applied and what are in an early stage. So, such coordination, of course, supports the research and guides it. And our research institutions have to restructure their research products to achieve practical results. So, and as for today, this 2020 program, it's not just a program of United Aircraft Corporation or that of SAGI. This is a joint program guided by our steering committee, which makes decision on how money should be used and what technologies should be selected. So that's why we consider that the developed system is our mutual know-how, and it was presented in Europe and in other regions, and it got acclaim from our partners and is a modern model for transition from creating a scientific baseline to production of specific aircraft models. So, and as I am speaking on behalf of the United Aircraft Corporation, you probably know that the corporation is in charge of production of civil aircrafts and warplanes and unmanned aerial vehicles, and the database developed allows us to use all the technologies in all the projects. And as for today, we are running more than 20 projects in different industry segments, which are at different stage of readiness. So actually we are governing the process, and we are very happy that as for today our science is once again part of this integrated process, and we are very grateful to our scientists. So I would like to stop here. Many thanks. Okay, thank you so much. Let's continue. And our next speaker is Mr. Vladimir Makarekin, the head of Helicopters of Russia Holding, head of research and public programs. Good afternoon, dear colleagues. So I'm representing the Helicopters of Russia, which unites developers and serial producers of helicopters, which are being supplied to Russian and foreign markets. And we have a number of types and modifications of helicopters being supplied to the market. So the key message of our Innovations Forum is the need to combine the requirements of industry and the science, which is an important component of our business. So as for today, huge attention is being paid to the means of transportation passengers and cargoes. And as for helicopters, I would talk about transport availability as is the focus worldwide for today. I remember the conference in Madrid in 2011, when the borders for aviation transports were highlighted, like any geographical point in Europe, 4 times from departure to arrival. And as Mr. Sergey said, talking about foresight, so we need to reduce carbon dioxide and nitrogen oxides emission. We need to cut those emissions. So in that case, aviation would look like teleporting. So even if we manage to sort out at least part of those problems, they will become part of certification requirement. And of course, developers will be able to attain the leading positions. So if we talk about helicopter aviation, I would like to show you the entire transportation system and its development as part of the entire transportation system development in Russia. You see free areas and development areas both for rail and motor transport, which is gaining speed, and helicopters should find their place. It also has to do with a network of airports, national and regional. So by 2020, it would include 350 airports, which is and landing points. So in Soviet times, the number was 1,300. So obviously 350 is not too much for Russia. But the key question is how you provide for transportation accessibility between those points. And as for tasks met by helicopter aviations, I think they are quite clear. And you see these circles, which stand for the zones which show the transport accessibility throughout the country. Yeah, and we also need to take into account tasks which our customers may request, and there are different destinations, different models of helicopters being used, and this is an illustration of how this could be achieved. In terms of speed, helicopters could be comparable with the capacity of cargo. Aircrafts, they don't need special arrangements. Some smaller helicopter pads are enough, and they could be used for law enforcement and for survey purposes. But to meet those tasks as part of helicopter aviation, we need to be ready to solve serious tasks on the worldwide level, in line with foresights, as mentioned by Sergei Chernyshov, in terms of flight safety and creating smart on-board equipment for all classes of helicopters, and we need to move to new type of technologies, because in helicopter you see the need for using electrical equipment for propelling force and the thrust of a helicopter. So as for the timeline, we used our corporate process platform called Vertical, which is in line with the foresights and is linked to high-performance aerial vehicles and covers their velocity, safety, ecological and intellectual aspects, and they are all in line with the level of technology readiness. So, as Leonid Kom just mentioned, we need to know where is the limit for technology and the beginning of the production. I would like to say a couple of words on cooperation. So this large-scale task is being updated at the moment. So we see a number of technologies, and each sub-program is divided into a number of clusters. And in each cluster, you see a research scope. And it's impossible to carry it out alone or without cooperation. All those works are within framework requirements, which are made the basis for development according to the national program for national development of aviation. Together with the United Aircraft Corporations, we are one of the key partners of TSAGI, because even if the market doesn't demand high-speed flight on a helicopter, so we know that we have engineering tasks in front of us, and in our opinion, it is at a level that the aircraft designers have to meet when moving from normal to supersonic speed. So we also need to focus on air compression and vibration and the vortex flow, also technologies of individual blade control, control of the powertrain. So all those controls should be integrated, and our vertical platform is being updated at the moment. Then it would be passed to TSAGI and other research institutes. TSAGI is the key institution which coordinates development of technologies in the aviation, and some other corporations, including United Aircraft Corporation. So the high-speed transfer will be resolved together with the United Aircraft Corporation. We have a number of framework programs, like Vision 2020 program, which was launched back in 2014. We are looking for partners in terms of airflow acoustics, and we have a number of partners abroad. And also, there are some Russian corporations which are part of the Rostec Corporation. So the basic principle under those partnership programs is establishing priorities. And the key thing is not to work over one or two or three technologies, but to provide a complex of technologies in a moment of time, which would allow us to develop an aerial vehicle or to upgrade helicopters, or rotary wing machines being produced. So that's why for us, questions which have been resolved by adjacent industries and research corporations are so important. Thank you so much.
Thank you very much. And now aviation, we must say this is a global industry, and it's very important to have international cooperation here. So we would like to give the floor now to Leonid Sorkin, the head of the chairman of the board of directors of Honeywell Company. Please, you have the floor. Thank you very much. Dear colleagues, I think that due to the fact that our topic is aviation innovations, I shouldn't say anything about Honeywell. I just like to say that as in Intel inside in PCs, Honeywell inside in aircrafts, and in very many platforms, it is in place. So I'd like to continue the topic touched upon by Mr. Okolov about Internet. He told us about the Internet to solve business solutions and business tasks of airlines. And I'd like to tell you about our innovation development, which we now bring to market. This is providing of passengers with high-speed wireless internet on board. And you know, we've been dealing with this topic for a long time, and we've surveyed thousands of passengers, and we asked them what is more important for them, to get a place closer to the emergency exit with higher comfort on board, or to have high-speed wireless internet during the whole flight. And the answer which dominated, that the high-speed internet is more important. So we have such an innovation development, and I'd like to quote a message from our official press release from May 2014. Honeywell will be an exclusive provider of equipment to provide onboard communication system for TNT company, which plans to provide services of high-speed wireless connection on domestic flights, commercial flights in the U.S. Owing to GLTE, passengers can enjoy very high-speed data transfer on board. The planned launch is at the end of 2015, and the similar statement was made for the airline Air China. The new era of onboard internet on commercial flight and its unprecedented speed and bandwidth would make Air China closer to provide passengers with a high-speed internet on the height of 20 kilometers in the form as they have home or in their office. This is an innovation development for flight passengers. Now, let's talk about two other innovations, one of which, the first one, is not in the market yet, and if it will be placed on the market, so it is only in 2016, and one of them is already in the market. And both of them are connected with energy efficiency of the flights. The first innovation is electrical, environmental friendly driving and taxiing system. What is it about? Using electricity in the supporting power unit and electric drives for the driving wheels of the aircraft, the system allows to make taxiing without using aviation engines. On our estimations on the mid-haul flights, the saving will be up to 7% of the whole fuel consumed for the flight. Basically, this is a very high number and a very serious environmental thing for airports. This is our joint development with Safran company. And as I already mentioned, in 2016 we plan to install this system on new aircrafts and on upgraded aircrafts. The second innovation is another energy-saving solution. This is basically an old news, but in the time it was announced, it was related to small business planes. And now I'll tell you about it in a moment. And this novelty has been spread out widely. This is the fueling of planes with biofuel in the ratio of 50-50, 50% for biofuel, 50% of aviation kerosene. Our statement is quite old. We fueled our own Honeywell corporate flight in Paris, 18th June 2014. Honeywell announced the successful use of green fuel used on Gulfstream G450, making the first transatlantic flight from North America to Europe using biofuel. The plane landed today in the Bourget airport. Basically, it flew out from our New Jersey headquarters on the Charles Lindbergh flight over Atlantics. The biofuel was generated from a special mushroom which was planted on big fields. I'd like to stress it that we use these feedstock for biofuel only and we use only plants of non-agricultural purposes, and which is not included in food chains. So we just use orange milky caps. This is a product which is not used in food chains of cattle. So the use of these materials is allowed by practically all aircraft producers and engine producers, and basically it is very pleasant for me to say that here we have representatives of this company. The first aircraft used the Rolls-Royce engine, and the flights from US to Japan now are for half fueled by biofuel. Our innovation were related to the creation of technologies for production of biofuel from the green mass. And the last point in my presentation is that I'm very pleased to have a floor here after the colleagues whom we have long-term business relations. We respect them very much, and we're also very glad that we can take part in their programs. I speak first of all about the United Aircraft Corporations, and we have also very good relations with TAGI and Helicopters of Russia. Thank you very much. Thank you. And now we will have another presentation about one more innovation, which is very unique, because this innovation is not of a subject matter. It's not a new device or something. It is just an infrastructural approach. And now Mr. Steve Morris, the General Director of Aircom Company on EMEA countries, will tell you about the concepts of airtropolises. Please.
Hello everybody, I hope you don't mind me standing up, and I hope you don't mind me speaking in English, because my Russian unfortunately is not very good, so you might want to put your machines on. ACOM has been in Russia for over 20 years. We're very proud to work here. ACOM's part of the largest transportation consultancy, over 100,000 people, and operating across all modes of transport. So our idea for innovation comes from a very old idea, and it's about trade and cities and the role of transportation in really generating economic wealth. So this is a very old picture of about 900 years ago, and it tells us why Moscow is here today. It's on the route of a whole load of trade channels. Cities have always existed because they trade and they exchange. And this is the heart of transportation, is to create wealth and to create trade and to make connections. And right from the very earliest stages, cities, the red circle in the middle is Moscow, form where trade comes together. And then cities now across the world compete with each other. And they compete for trade. And more of our people, 75% of the whole world is living on cities, and more people will live in cities in the future. And more urbanization means more need to connect. And in some ways, cities are becoming more important than countries. And cities only exist to trade and to exchange ideas. And everything that else that goes on in a city is secondary. And you can think about trade between countries like China and Russia and the UK. But actually the relationships between the big cities, between Moscow, between Shanghai, between London, is extremely important. It's a strong connection that we make between those cities, and that connection becomes stronger. And if you look at the economic development, it's clear that this is a game of urban development in which some cities are winners and they develop very quickly, and some cities lose and they lose trade and they lose importance on the global platform. Dubai has shown recently that a real focus on becoming a connecting city can really make a huge difference to the wealth. So real investment and focus in this area can make a big difference. And the biggest, most connected cities win, become more rich, become more developed, and more wealth flows in. So what is the point? This is a map of a group of cities. And if you look at how they connect themselves, if every city connects to every other city, it's a very complicated operation. But if you have in place a simple hub and spoke arrangement, that is the most effective way of getting cities to connect with each other. And so it becomes very important to be a hub city. Now you may ask, in the generation of internet, and we hear from our respected colleagues in Honeywell the importance of internet, why do we need to travel? And it's very interesting. If you map the development of internet communications, then it gives a very clear idea of where the investment in aviation will come in about 5 years' time. And that's because, first of all, we start talking to each other, and then we start trading and exchanging and connecting with each other. This is the map of internet traffic across Western Europe, and if I now overlay the map of aviation travel, you can see it's very, very similar. There's a clear link between internet development and then aviation. And on this map of aviation for the whole world, the red circle here is Moscow. And I think the big question for Russia, for Moscow, is how does Moscow want to be seen in this big competition for global trade? And what is the role of aviation in all of that? Because it's hugely important. I see I've been looking at the audience over the last hour. I see many of you have these iPhones. Everybody got an iPhone? A lot of you have got it. iPhone 6 maybe? So now, where does your iPhone in Moscow come from? Well, it's specialist equipment providers in America, in Switzerland, in Germany, in Asia, in Hong Kong, in China, in Japan, and they are all bringing their specialist equipment in this iPhone through aviation into Shenzhen, where the iPhone is assembled, and then it's flown into Amsterdam, and then it's flown out to Moscow, and that's how our iPhones end up in Moscow. So aviation isn't only about passenger transport, it's very critical for trade, and I think we all know this. 40% of the whole world's trade goes by air. So we can't ignore this trade. It's hugely important to all of our cities. And it's very interesting that aviation grows and grows and grows. This slide shows the big line of 5 to 6% growth per year in aviation. On the bottom, those big circles show the big problems in the world economy. 9/11, oil crisis, the latest economic crisis. But throughout all of that, aviation keeps on growing, because in the last economic crisis, when aviation dropped in the West, you can see from that graph, it continued to rise in the East. It's hugely important. It's a very, very complicated slide, but it makes the point that our esteemed colleagues made earlier, that the transport, aviation, is a very sustainable way, and with new biofuel technology and the great technical developments you heard from the earlier speakers, only 1.6% of the world's carbon dioxide is produced out of aviation, and that's decreasing all the time, and it's much more efficient to go by air and to trade by air than any other means. So our innovation is about the connection between this really important aviation way, the airport, which is how this connects with the city. Traditionally, in a city like Moscow or London, then you have this sort of arrangement. You have a city, you have an airport, and then around the airports there's some random developments to develop. We believe that the idea of an aerotropolis, an economic zone around the airport, well planned, well invested in, which specialises in some of the things that make an iPhone and other trades, is a great way of linking the airport to the city. We think they shouldn't be two separate things. We think they can be connected by this idea of Aerotropolis. And by doing this, we can concentrate the power of the city and make it more powerful and more efficient. And we can do this in a way that really helps the city to become really good at connecting and competing with Dubai, with London, with Amsterdam, for us here in Moscow. By connecting, by specialising and developing these sustainable cities as a result. And around, so what is an aerotropolis? It's like a small city around an airport with all the sorts of things that you'd find around a city, but very well connected into the city. And we in AECOM are very much involved with a number of these kind of developments. They're very successful. This is a picture of Munich, which is like a downtown, Munich airport. It's like a part of downtown Munich now, and it's been developed like that. And even leisure activities are working through there. Economically, the facts support that this is really important. For every major long-haul flight there is out of Moscow or out of London, there are 3,000 jobs for every new route that are created directly or indirectly. And these are high-value, high-economic jobs. And every time we increase the passengers through an airport, then the regional economy around that airport increases by about 2%. And about 1 in 6 of everybody in the world lives now within 20 minutes of an airport. I won't go through these slides of the work we're doing in London, but it's an example of where a city has started to lose connectivity because an airport doesn't work very well, and we're designing something that will make a difference there. So I think the question for Moscow is how much do we want to compete in this game? And this is also an issue for the other regional cities. I've picked Domodedovo here, but we work in Sheremetyevo and Polkovo and so on. But can we develop together a plan which brings industry and the aviation side of things together to create the kind of wealth in Moscow that will mean that it'll be a super city of the future and really continue to compete on the global stage and important there, as it has been doing for about 1,000 years. So that's our innovation. I think it works very well with the technological innovations everybody else has talked about. Thank you very much for your time and consideration.
Thank you, Steve. И сейчас мы переходим к нашему.
Now we would like to move to our next presentation, and this is the closing presentation. So we remember how Valery Okolov talked about unmanned aviation. So we will also finish with a presentation on unmanned aerial vehicles. Okay, please introduce yourself. Hello, I'm Andrei Mamontov, head of Aero company representing unmanned aviation. So I see unmanned aviation as a very promising field for introducing innovations, because unmanned aerial vehicles have a very short period for introducing innovations compared to regular manned aviation. Because on the one hand, a lot of new process solutions could be applied and used, but on the other hand, not all of them are well proven. At the moment, we have a number of companies involved in unmanned aerial vehicles, and little by little we see that regulations are being introduced to that type of aviation, on top of what Valery Okolov said. we don't only need automatic dependent surveillance systems, but also special regulations, and SAGI and other companies are involved. And in unmanned aerial and unmanned aviation, innovations could be divided into new process-related materials, because they mainly use composites, which allow to develop the entire industry, and also new design schemes, because design of unmanned vehicles could be very different from what is used in common aviation. This is also use of software systems and automation systems. So we have a lot of challenges, but the main problem is not creating something new, but to making innovations serial and introduce them. So we are trying to work intensively in this area. I know that Rostec have created a number of working groups that collect process solutions that could be later on integrated in a consortium that could further on assign tasks to corporations. For instance, if you have a company focused on composites, it could be used for developing the airplane body and so on. And based on data for competencies in unmanned aviations, special purpose interdisciplinary program is being developed by Vega concern, and it will be improved by the Ministry of Economy and Trade. So this is a special purpose program for the period of 2015-2023, and it has to do with all types of aviations, including smaller aircrafts used for survey and mapping, and also with heavy aircrafts, which account for the largest part of the market at the moment. And the involvement of younger development teams is very important for those innovation programs. And some institutions like Skolkovo Foundation, it has around 6 companies in aerospace cluster. So 6 teams are related to unmanned aviation. So they are ready to provide us with process solutions. So they mainly include design offices, which focus on certain breakthrough applications and ideas. Well, and I think will not waste our time, so let's now move to the question and answer session. I think we almost made our schedule, and so let's move to the Q&A session. But my request would be, please use the microphone for the interpreters to be able to translate, and also introduce yourself. Good afternoon, I'm Nikolai Litvinov from the machine building department of the company. So I have a brief question to Valery Leonidovich. So you showed us an aircraft body with 3 engines. So please let us know why 3 engines are used, for safety precautions, or just for the air stability. And could I please move to my second question. My second question is to Honeywell. You mentioned that Wi-Fi reduces the space between the seats in the aircraft. But my question is, would it be necessary to put screens in front of a passenger on an airline? Maybe we could do without it. Thank you. Okay, so the first question goes to me. So this is one of the options. So, and together with the United Aircraft Corporations, we reviewed a number of options, and there is an option for the longer run, like 2030 maybe. So the conception of a distributed wing with dozens of engines, and you have a power generator on board and powerful batteries with fuel cells that allow to support autonomous mode for the plane for a number of hours, and the generator keeps recharging batteries. So in that case, we can use dozens of engines distributed across the top surface of the aircraft to use that screen effect and reduce the noise. So this is one of the options. And also gas turbine engines could be used, and the less is the number, the easier to operate them. This is the world trend. But we examined a number of options, and it was just occasionally that we had an image of a plane with 3 engines. Thanks for the questions. So I should have put it differently. So before we started to think about high-speed internet access on board, so we decided to ask passengers, and we polled 1,000 people, and they said that high-speed internet for them is more important than comfort. So if you check in and get a service close to the emergency entrance. So as for the screens, when everybody has gadget, so this is not a question to us, but maybe to the United Aviation Corporation or to Boeing, because we don't design airplanes, we only produce components. But as a passenger, and I fly a lot on the week, and I had a flight to Vladivostok, so I would always watch a movie on the airplane screen, not on my gadget. I think it's good that you have that opportunity. A question from Rosnano, Artem Rybalko. So the wear out level of technologies. So how do you detect or identify it as compared to the number of technologies being used? Well, actually, there is a scale with a score of 9 for each stage. You have requirements a technology should respond to in order to be assigned a level. So this is a generic scale, not just for aviation alone, but for other processes. And you have a special level calculator which allow experts to use computers to key in certain characteristics and to get the final integral index. So the software product is used to reduce the number of questions. So this scale was developed in our work with research institutes in order to give objective evaluation to our work. But we believe it would be very nice that such sort of scale could be approved by the state. In the United States, NASA and Pentagon and other public institutions, they use a similar type of scale. And I would like to add, so if we come to you with a technology and if we say our technology is in line with level 7, would you believe us or would you check it using some internal criteria? We will just ask you some questions you will have to answer, and we will be based on the fact that you are answering us honestly. Andrei, for level 7, it should not be just a model, but a prototype working in real life, subject to operation. So if you would show it to us, then it would be good evidence. Andrei Oblonsky from Airfloat, Director on Development. As for Aeropolis, I have a question to Leonid and a question on gadgets on board. So last year we had a contest on this service for using equipment on board with our colleagues from Israel. And there was a trend for using proper gadgets. For that, to this end, you need a server and acceptance. So you will be able to look at what is required on board. But from the point of view of those who operate the equipment, what's required, the need is to reduce the weight of equipment. And at the moment, everybody's struggling to make lighter devices. And the results of our research shown that this is really so. So my question to Leonid and to Sergey is, you just mentioned the number of engines which could be placed on board. So developments which are currently being led by Sergey, and we also remember about Superjet, so we can find ourselves in a situation we were already before previously. And I mean that while fuel cells of generation 4 would reach the certain level of power, they will replace the auxiliary power block, and then they would not be allowed into European market because the CO2 emission is quite high. So I would like to ask you whether you take into account those risks. And also a question to our estimated helicopter builder, helicopter designers. So we remember Me-12, a very exciting designs and an all-round designs for the national economy. But a question is on how to restrict CO2 emissions. So may I begin with your permission? In my brief presentation, I said that for science, the initial point is the requirements which would be justified in 10, in 20 years in safety, in ecology, in noise reduction, and building developing new technologies and new machinery, new equipment today, we should be guided by future requirements, and this would be a guarantee that by the time we produce an aircraft, it would be in line with environmental and noise and comfort requirements for some years. And of course, those requirements are not stringent. They change. Of course, in 2 or 3 years, we will have, you know, that in terms of noise, we have Article 14, which is obligatory for the aircraft builders, and we need to take it into account. But as for gadgets, this question is philosophical. Of course, we are moving towards more electronic systems, to a smart board, a smart cockpit, where you have people controlling the aircraft. They need comfort, they need to feel as if they were on the land. So I fly a lot with a business class, and as for me, I value the chance to have some rest from the continuous communication from my emails. So my priority would be comfort and peace on board. Well, maybe for scientific reasons, communications are required. Now, a question about fuel elements. Sorry, I forgot about fuel elements. As for fuel elements, this is of course a very promising area. We have current works, and of course this is the research and the corporations are focusing on that. So, in brief, in our country, many institutions, including academic research institutions from Kurchatov Institute and non-research institutions, are working on fuel cells, and the level they have reached allowed us to show our Minister of Defense an unmanned vehicle with fuel cells, which we have a video how noiseless, which maintains its position in the air for a long period of time. And secondly, of course, it's impossible to put fuel elements on a plane of an older design, so that's why we are resolving the problem in a program targeted at a higher level of electricity in an airplane. But it requires that the output of the fuel element should be 150 to 200 kilowatts. And as for today, the specific characteristics of fuel cells do not allow us to produce a compact auxiliary power unit working on a fuel cells.
The third thing, it's clear that the aircraft during its life is being upgraded several times. And as soon and so far we are oriented in our future models to the gas turbine supporting power units. But as soon as the industrial samples of such fuel cells come out, which would allow to fit into necessary characteristics and dimensions, it would be very easy to replace the power unit on fuel cells, because it is installed in a separate compartment and it won't be a problem. So we have the same the same small gap between what science does and what industry can implement. We evaluate the fuel cells technology on the level of 3.5, but we need 6 kilogram per kilowatt of power. It is quite enough to replace it, right? 60 kilowatt that we have, and we will have 200. You say when we will have it. As soon as we have it, we will do it. Shall we include maybe some interested parties here, stakeholders in the aviation? Yes, you're absolutely right. I won't tell you how we stimulate, intensifies, and finance, and even speed up this program in order to get these fuel elements as soon as possible. Shall I tell you in detail what are the perspectives? It is connected with the efficiency of the scheme. Yes, there is a framework, the scheme, which is really temptative, but so far the characteristics are worse than the characteristics of membrane permeability systems. I'm sorry, I beg your pardon, dear ladies and gentlemen. We are out of schedule that we have. The discussion is very interesting. Presentation was very interesting. Unfortunately, it's not possible to discuss anything within one round table. It's clear that this job will be continued, and I'd like to appreciate and thank all participants and all organizers for invitation. I'd like to express my gratitude for presenters for very interesting presentations, and thank you for your questions. Thank you very much. It is finished.